Example 1, for the triangle shown, find the sine, the cosine, and the tangent for angle B. Here's our triangle. Actually, theirs went the other way. So to make it easier, we've got A over here, 4 meters here, 3 meters here. Here's my little seaside. Okay. So I'm not given either angle measurements, I'm given 2 side lengths. So it says they want us to find sine B, cosine B, and tangent of B. So let's start with the sine for angle B. So the sine for angle B, what's our formula for sine? Sine equals opposite over hypotenuse. So the sine for angle B equals the opposite side, so that's my 4 meters, over the hypotenuse, which I don't know. Cosine for angle B, cosine is adjacent over hypotenuse. So which side is the adjacent to the angle B side? The 3 over my hypotenuse. Tangent for angle B, the tangent is opposite over adjacent. So opposite of the big B, the little b, opposite over adjacent. So I do know both of those. So let's solve for the tangent. So 4 divided by 3 equals 1.333. And then if I hit second function, tangent, angle B equals 53.13 degrees. Let's go back and solve for everything else that we're missing. So if I know angle B is 53.13, what's the easy way to figure out what angle A is? Right, angle A plus 53.13 has to equal how many degrees? 90 degrees. So 90 minus 53.13, angle A equals 36.87. We're going to go through and verify that using some of our functions. Now that we've solved for angle B, let's go back and do the sine and the cosine and make sure that we get the same length for the hypotenuse for both of those. Let's go the sine for angle B, 53.13. What's our formula for sine? Sine equals opposite over hypotenuse. So the sine is opposite over hypotenuse. And I don't know the hypotenuse, so that's what I'm solving for. How do I get that little c all alone? Here's a little shortcut. The long way is times both sides of the equation by c, so that it comes out from the bottom of the fraction. And then divide by 53.13 on both sides so I can get the c alone. So the shortcut way is these two switch places. So I rewrite it like this. C equals 4 over the sine of 53.13. So if my unknown is on the denominator, I need to switch those places so that it goes to the other side of the equal sign. So to solve that with our calculator, type in 4 divided by 53.13 sine equals, and I get 5.00000669, so we're going to call that 5. So So let's verify that using our cosine formula. So if I do the cosine for angle A, angle B, the cosine for angle B, 53.13. So my cosine formula is cosine equals adjacent over hypotenuse. So which is the adjacent side to the angle B? So 3 over the hypotenuse. So again, we're solving for that little c. It's the denominator, so these need to switch. So c equals 3 over 53.13. So same, grab your calculator. 3 divided by 53.13 second cosine. Forgot to write that on there, didn't I? Cosine. What did we end up with? $4.9999. Anybody else not get that? Okay, so we'll call that 5. 4.999988091. So C equals 5. We're doing okay. We verified it using 2 different formulas. So we'll say side C is 5 meters. The last thing I want to verify with you is this angle A measurement. 36.87. So let's use one of these formulas. Now that we have all 3 side lengths, let's do either sine, cosine, or tangent for angle A. So which one should we use? Tangent? Okay, we haven't used that yet. If I do the tangent of angle A, so come back to our triangle, which is adjacent and which is opposite? Okay, so across the triangle from angle A is my opposite side. That's my 3 meters. So tangent is opposite over adjacent. The adjacent to angle A, 4 meters. So the tangent for angle A is 3 divided by 4, 0.75. Second function tangent, A equals 36.87. Okay, so we did okay. Those matched up. Or I could have looked in my book on page 179, the table of trigonometric functions, and found the closest degree measurement to 0.75 as my tangent value. So in trigonometry, as long as I'm given 2 pieces of information, I can usually solve for everything else on the triangle. Let's keep going in the book on page 165. And we'll do right there in the middle of the page. Try this one, number 1. Here's our triangle. Set. They're given a B side length of 12 inches and an A side length of 5 inches. So what am I missing? I'm missing both my angles and my hypotenuse. So where should we start? Well, I don't know the hypotenuse. So which of the formulas can I not use? Okay, I can't use sine because I need the hypotenuse. And I can't use cosine because I need the hypotenuse. So I can use tangent. So let's start there. Let's do tangent for angle A. So tangent equals opposite over adjacent. So opposite of angle A is my 5-inch side, and adjacent to angle A, a 12-inch side. So the tangent of angle A equals 0.4166 So then second function, tangent, A equals, let's say 22.62 degrees. Let's then do the tangent for angle B and make sure that A and B together add up to 90. So tangent, opposite over adjacent. Which side is opposite the angle B? Okay, the little b side is opposite. And then adjacent to the angle B, the little a side. So the tangent for angle B is equal to 2.4. So either table or calculator. Second function, tangent, B equals 67.38. 67.38 plus 22.62 is 90. We're doing okay so far. So there's angle A and angle B. Now what am I missing still? Okay, I'm still missing the side length of C. So there's a lot of ways we can do it. Okay, let's try cosine. Cosine for angle B. So cosine is adjacent over hypotenuse. Which side is adjacent to the angle B? Okay, our side 5 over the hypotenuse. So then I need to plug in my angle B measurement right here, 67.38. So the cosine 67.38 equals 5 over C. Remember, I need to get the C alone. So where do I move it to? Okay, shortcut, those swap spots. So C is equal to 5 over the cosine of 67.38. Grab your calculator. 5 divided by 67.38 cosine equals C equals 12.9999. Call that 13. So let's make sure our hypotenuse is the longest length. We have a 5, a 12, and a 13. We're still safe. Let's go back and do the sine then for angle B. Make sure we get the same value. The formula for sine, opposite over hypotenuse. So the opposite side is our little b side, which is 12, over the hypotenuse, which we're trying to solve for. So the sine of 67.38 degrees is equal to 12 over c. Okay, so swap those spots. C is equal to 12 divided by the sine of 67.38. 12 divided by 67.38 sine equals 13.0000. I think we're safe to say our hypotenuse length is 13. So now I could go back and check my angle measurements and use 13 as my hypotenuse in either sine or cosine, or I can use the Pythagorean theorem and do a squared plus b squared equals c squared to verify that that is 13. So you always want to check your work when you're doing trigonometry. Make sure that everything matches up. So keep going in the book. Bottom of page 165, example 2. Now they give us one angle and one side length. Here's our triangle. Our side length of B, 200 feet. And our angle A is 30 degrees. So what's the easy way to know what angle B is? Right, A plus B equals 90, so you're going to guess, okay, 60 degrees. So angle B is a 60-degree angle. Let's verify that using our formulas. So the first thing we want to find is, what do we know? I know an angle and a side length. Which side length do I know in relation to angle A? Very good. I know the adjacent side, so that means I need to use something with the adjacent. So let's say I want to solve for the hypotenuse first. I have an angle and the adjacent side, and I'm solving for the hypotenuse. Which formula should I use? Okay, the sine for angle A equals the adjacent side over the hypotenuse. So then plug in what you know. Angle A is a 30-degree angle, and B is 200 feet over my hypotenuse. Okay, so switch those sides. The hypotenuse equals 200 feet divided by the sine of 30 degrees. Grab your calculator. 200 divided by 30 sine equals 400. So C equals 400. And what's our units? Feet. C equals 400 feet. So I have my side length for B and the hypotenuse side. What am I missing? Side A. So let's keep using angle A here. Which is the side in relation to angle A that I'm still missing? Okay, little side A. So that is opposite of angle A. So which formula does opposite over hypotenuse? Okay, so we made a mistake here, didn't we? So the sign for A is opposite over hypotenuse. So that should have been my little a instead of the B, which I didn't know that one. I didn't know the little a side, so this is all incorrect. Okay, you want to try it again, Eric? Okay, walk us through. Sine of A. Sine of A equals what?
Around 1.
Opposite over hypotenuse. I don't know my opposite side yet, do I? I know which side? The adjacent side. So which formula uses the adjacent side? So the cosine for angle A. So adjacent is the little b side over the hypotenuse. So then plug in what we know. So the cosine for 30 degrees is equal to what? 200 over C. Okay, solving for C, so C needs to come all over by itself. 200 divided by the cosine of 30. Grab your calculator. 200 divided by 30 cosine equals, so my C length is 230.94. So let's verify that. If I know angle A is a 30-degree angle, then I know angle B is 60-degree angle. So let's use angle B to check our hypotenuse length. So I'm given 200 feet, and that is opposite or adjacent to angle B? Opposite. Okay, so if we do the sine for angle B, it is the opposite side over the hypotenuse. So we fill in what we know. Angle B is a 60-degree angle, Our little b side is 200 feet over the hypotenuse. Solve for c. 200 divided by 60 sine equals. $230.94. Okay, so C and C. So we have our angle A, 30 degrees, our angle B, 60 degrees, our hypotenuse side length, 230.94. We're just missing this side length A. So let's continue to use the information they gave us in the problem. So they gave us an angle and a side length. How can we use those to figure out this missing side A? Which of the ratios do we need to use? So I have angle A and the side that is adjacent to angle A, and I need to solve for the side that is opposite. So that's our TOA. So tangent of angle A is equal to opposite over adjacent. So when I fill in what I know, tangent of 30 degrees is equal to the opposite side over the adjacent side. So now I need to get the little a alone. It's not in the bottom of my fraction, now it's on top. So if I multiply both sides of my equation by 200, I'll get my little a alone. So a equals 200 times tangent of 30 degrees. So 30 tan times 200 on my calculator. A equals 115.47. $115.47. Is there another way that we could verify that? Pythagorean theorem, okay. So tell me about that one, Eddie. A squared plus b squared equals c squared. So what are the values we're going to use? We're checking for a, so we don't know that one yet. A squared plus, what's our b squared? B is 200. 200 squared equals, C is 230.94. So 230.94 squared. 230.94 squared minus 200 squared equals, so a squared equals 1333.28. Take the square root. A equals 115.47. Okay, so we got the same thing. So we solved for C, we solved for A, and we solved for the angle B. So they gave us two things and we solved for everything else. Okay, keep going in your book. Page 166, try this one. It's written out, there's no diagram. It says, in the right angle triangle ABC, so draw your triangle first thing. In the right angle triangle ABC, find the length of side B. So that little m, the measure of angle B is 58 degrees. And side A equals 12 inches. They gave us a degree and a side length, and they need us to find, well, they're asking us to find the length of side B, but we're going to solve for everything. So let's start by solving for angle A. Angle A plus angle B equals 90 degrees. So if angle B is 58, what does angle A equal? So 90 minus 58, angle A is equal to 32. So now let's solve for side length B. I have both angles and one side length. Can I use the hypotenuse to help me solve for side length B? No, I can't. I don't have that yet. So which of the formulas can I not use? Okay, I can't use sine or cosine because they both use the hypotenuse. So if I want to use the information given, I need to use tangent. Doesn't matter which one. Very good. We can use either tangent A or tangent B. We're working with an opposite and adjacent in both cases. So let's do both to make sure we get the same thing. So if I do the tangent for angle A, tangent equals opposite over adjacent. So tangent for A. So opposite of A, little side A, is 12 inches over adjacent. There's my little b side that I don't know. A is 32 degrees. So the tangent of 32 degrees is equal to 12 over b. My little b is in the denominator, so I need to switch those places. The little b equals 12 divided by the tangent of 32 degrees. Grab your calculator. 12 divided by 32 tangent equals 19.20. 19.20. Okay, now let's use angle B and make sure we do the same thing. So the tangent for angle B, which is 58 degrees, equals opposite over adjacent. So opposite, my big B is my little b, and then adjacent is the 12 inches. So I need to get my little b alone. So I multiply both sides of the equation by 12. Then I have b equals 12 times tangent of 58 degrees. Okay, so grab your calculator. 58 tangent times 12 equals 19.20. So there's our side length B, 19.20. We got the same thing in both cases. 19.20. So the only thing we're missing now is side length C. So now that I have both angles and both side lengths, which equation do you want to use? Okay, let's do a cosine. So cosine, which angle? Both? Okay, we can do both. Cosine for angle A. So cosine equals what? Adjacent over hypotenuse. So adjacent to the angle A, the little b side. Just plug in what we know. Cosine 32 degrees equals b, so we need our b side length right here, 19.20 over my hypotenuse, which I don't know yet. So swap those out. Hypotenuse equals 19.20 divided by cosine of 32 degrees. 19.20 divided by 32 cosine equals, so side length C, 22.64. What's our units? Is inches. Is that our longest length? Yes, we have 12, 19.20, and 22.64. Okay, so then let's try the other way too. Cosine for angle B. So cosine is adjacent over hypotenuse. So adjacent to the angle B is the side A. 12 over the hypotenuse. So our angle B is 58 degrees. So cosine for 58 equals 12 over C. C equals 12 over the cosine of 58 degrees. 12 divided by 58 cosine equals 22.64. Here's my inches. There's my side length C. I have a side length B. Both angles. Call that one done. Move on in the middle of page 166. Find a side of the triangle using cosine. So they give us our triangle here. Our little B side, our little C side, they give us an A value of 24 feet and a B angle of 72 degrees. So we'll solve for everything else. Where should we start? I have an angle and a side length. And in relation to each other, is that the opposite or the adjacent side? Adjacent. Okay. So let's do cosine for angle B equals the adjacent side over the hypotenuse. So then plug in what we know. B is a 72 degree angle. My side length A is 24 feet over the hypotenuse. Switch those spots. C equals 24 over cosine of 72 degrees. 24 divided by 72 cosine equals C equals 77.67 feet. .67 feet is our side length C. Let's find angle A now that we have two side lengths. So I have a hypotenuse, and then which side do I have in relation to angle A? I have the opposite. So what's the formula for opposite over hypotenuse? Okay, so the sign for angle A is equal to the opposite side over the hypotenuse. So let's use 77.67 for our hypotenuse. 77.67. Grab your calculator. 24 divided by 77.67 equals 0.308999614. So then this is where I need to use either my table in the book or second function on the calculator. So hit second function, sine. So angle A equals 17.9989. We're going to call that 18 degrees. Angle A is 18 degrees. Does that add up? 72 plus what is 90? 18. Okay. Now I know angle A is 18 degrees. I know angle B is 72. I have a side length A of 24 feet and a side length C of 77.67 feet. What am I missing? Okay, side length B. So if I don't use the Pythagorean theorem, let's use a different one. You choose. You tell me which one you want to use. Okay. So if I use angle A, which side am I trying to find in relation to angle B? Or sorry, angle A, which side am I trying to find in relation to angle A? The little b side, which is adjacent. Okay, so I need to use the cosine. Cosine for angle A is adjacent over hypotenuse. So then fill in what I know. Cosine of 18 degrees is the adjacent side, which I'm solving for, over the hypotenuse. We'll do 77.67. Okay. So I need to get the little b alone, times both sides by 77.67. So my little b side equals the cosine of 18 times 77.67. Okay, so grab your calculator. 18 cosine times 77.67 equals, so my little b side, 73.87. Is my hypotenuse still the longest length? Barely, huh? Okay. Let's verify that little b side. Let's use angle B this time. So what is side B in relation to angle B? Opposite or adjacent? Okay, it's opposite. So I can do the tangent of angle B, so tangent opposite over adjacent. So opposite of angle B is side B, and then adjacent side A. Put in what I know. B is 72 degrees. My little side B is the one we're trying to verify. And my side A, 24 feet. So I need to get the B alone. Times both sides by 24. So B equals 24 times the tangent of 72 degrees. 72 tan times 24 equals 73.87. And what's our unit? Feet. Okay. 73.87 feet. Okay, keep going in the book. Still on page 166, bottom of the page, try this one 3. It says in the right angle triangle, A, B, C, find the measure of side B when the measurement of angle A equals 53 degrees, and the hypotenuse, so there's side C, equals 18 centimeters. So I don't have little b, don't have little a, and I don't have angle B. So in relation to angle A, what do I know? Okay, I know the hypotenuse. So which of the two ratios can I use? Sine or cosine? Okay, let's do both. Let's do the sine for angle A. So sine A equals, right, opposite over hypotenuse. So opposite angle A is little side A. Plug in what I know. So sine for 53 degrees equals the little a side over the hypotenuse. So we need to get the little a alone, times both sides by 18. So the little a equals 18 times sine of 53 degrees. Calculator, 53 sine times 18. What did everybody get? $53 sine times 18. A equals 14. Oops. That didn't write very well, sorry. 14.375. So we can round up or down. Okay, round up. 14.38. So our A side, 14.38. So let's do the cosine for A. So cosine, remember, cosine is adjacent over hypotenuse. So adjacent to the angle A is the little b side. And fill in what we know. Cosine of 53 degrees equals the little b side over 18 centimeters. Okay. Little b alone times both sides by 18. So b equals 18 times the cosine of 53 degrees. 53 cosine times 18 equals 10.83 centimeters. So now I have an A length and a B length and a C length. Should we check using the Pythagorean theorem? A squared plus B squared equals C squared. Okay. So let's do A squared plus B squared. So I have 14.38 squared plus 10.83 squared. 14.38 squared plus 10.83 squared equals, so C squared equals 324.0733. If I take the square root of that, 18.002. Okay, so we knew 18.002, that's pretty darn close. So A and B, what else are we missing from the triangle? All right, we're just missing the measurement of angle B. So what's the shortcut way to do that? A plus B equals 90. So if A is 53, what does B have to equal? 37. So let's verify that using one of our equations. We haven't used tangent yet. Let's use that one. If I do the tangent for angle B, tangent equals opposite over adjacent. So opposite of angle B is the little b side over the little a side is adjacent. So fill in what we know. Trying to check my angle B. So my little b side was equal to 10.83. And my little a side, 14.38. 10.83 divided by 14.38 equals 0.753129346. So either use your second function, tangent, or the table in the book. So B equals 36.98. We'll round that up and say 37 degrees. Okay, can you start to see how you can always check yourself 10 different ways? We're going to move on and do the angles of elevation and angles of depression. And we can come back and do some more reviewing with the examples in the book if we want. Let's turn your page, 167. This says, the safety label on a 12-foot ladder says the ladder should not be placed at an angle steeper than 65 degrees with the ground. What is the closest safe distance between the base of the ladder and the wall? So here's our triangle. A, B, C. Okay. C is the ladder, and it tells me that that is a 12-foot ladder leaning up against a house. And it says the angle of the ladder and the ground, that's this angle right here, should not be steeper than 65. So 65-degree angle between the ladder and the ground. So I often draw myself a little picture. So here's my ladder, and then this is my building. They're asking me the safest distance between the base of the ladder, so from right here to the wall, right there. So that's the little side B that I need to solve for. So I'm given an angle and I'm given the hypotenuse. Which of the ratios should I use? I'm trying to solve for the little side B. Okay, that's adjacent to my angle, so I need to use the cosine for angle A is the adjacent over the hypotenuse. Then I know this is a 65-degree angle. I'm trying to find the side length of B. My hypotenuse is the 12-foot ladder. Multiply each side of the equation by 12. So B equals 12 times the cosine of 65 degrees. 65 cosine times 12 equals. So side length B is not quite 5.07 feet. So the distance between the base of the ladder and the house should be about 5 feet. How high up on the building is he going to come if he puts this ladder at a 65-degree angle? So then that's this little side A, right? That's the height up the building. So using angle A, that's the angle they gave me, in my 12-foot ladder, which formula should I use? So opposite of angle A, very good. So the sine for angle A equals the opposite side over the hypotenuse. A is still 65 degrees over my 12-foot ladder. So get the little a alone, multiply both sides by 12. There we go. 65 sine times 12 equals 10.87. Is how high up the building the ladder is going to reach. If you flip your page to the top of 168, it says, our homeowner is afraid of heights, however. He does not want to place the ladder any steeper than a 50-degree angle with the ground. Here's our house. Here's our ladder. This is now a 50-degree angle. It says how far up the wall will the ladder reach? So that's my little side A. Let's see how much height he loses by changing the angle of his ladder. So I want to repeat what I just did right here. So the sine for angle A is opposite over hypotenuse. Now my angle is a 50-degree angle. Still have a 12-foot ladder. Get A alone. 12 times sine of 50. 50 sine times 12 equals 9.19. So he'll only reach 9.19 feet up the house instead of 10.87 feet. Lost about 1.5 feet.